So, today we're going to tackle some of those math terms that can be, let's be honest, a little confusing, the vocabulary of functions. We're going to sort out the small but really important differences between these words so you walk away with a much clearer picture.
You ever been sitting in class and heard your teacher use words like range, image, and output, and it kind of feels like they're all just synonyms? You start to wonder, wait, are these the same thing or not? Well, that's the big question we're diving into.
And hey, if you've ever felt that way, you are definitely not alone. It's a super common hurdle, even for people who are great at math. But the good news is, we're going to clear it all up right now.
Okay, so here's our game plan. First, we'll talk about why these words get so mixed up. Then, we'll meet our 5 key players. After that, we'll see something cool, how one formula can actually create 2 totally different functions. Then, we'll learn to work backwards with a concept called the preimage, and finally, we'll tie it all together.
Right, let's get into it. Why is being picky about these words so important in math anyway?
Let's start with the basics. A function, at its core, is a really simple idea. Just think of it like a machine. You stick in a loud number in one end, the input, and it spits out exactly one number at the other end, the output. That one-to-one rule is everything.
Okay, time to build our toolkit. We're about to meet the 5 essential terms you need to speak the language of functions like a pro.
So this notation you see here, F:(A) arrow B, might look a little intense, but it's actually our secret map. Let's break it down. A is the domain. That's just the official set of all the inputs you're allowed to use. B is the codomain, which is the set of all possible outputs. Think of it as the target area. Then you have the image, which is the set of outputs the function actually hits. In school, you probably just call this the range. And finally, the preimage is our tool for working backward. It helps us find which inputs created a certain output.
Now, if you only remember one thing, make it this: the difference between codomain and image. The codomain is the broad universe of where your answers could land. The image is where they actually do. So the image is always inside the codomain, but it might be a much smaller part of it. Okay, let's put this into practice. This is where it gets really interesting, because we're about to see how one simple formula can represent 2 completely different functions. It really is all about context.
Let's use a formula we all know and love, f of x equals 2x. Super simple. But here's the twist. This formula all by itself doesn't actually tell us the whole story of the function. Now watch this. In case A, we say the domain and codomain are all real numbers. You put in any real number, you get out a real number. The image is all real numbers. Makes sense. But look at case B. Now we're only allowing natural numbers, 1, 2, 3, as our inputs and possible outputs. Suddenly, the image completely changes. The only outputs you can possibly get are the even natural numbers. It's the same formula, but a totally different set of results.
And that's the huge takeaway here. The context. The domain and codomain you set up at the beginning is just as critical as the formula itself for defining what the function actually is.
All right, let's grab our next tool, the preimage. This is what lets us flip the question around and ask, okay, I got this output, but which input or inputs got me here?
For this, we'll use a new function, q of x equals x squared plus 5. It's a great example for showing just how wild preimages can be. And just so we're all on the same page, we'll assume our domain and codomain are all real numbers.
So check this out. If we ask, what's the preimage of 9? We're looking for the x values that make x squared plus 5 equal 9. Well, both -2 and +2 work, so the preimage is a set with 2 numbers in it. What about the preimage of 5? Well, only an input of 0 will give you 5, so 1 preimage. And the preimage of 4? There's no real number you can square, add 5 to, and get 4, so its preimage is the empty set, nothing.
So, as we just saw, an output can have 0, 1, or even 2 preimages. But wait, there's more. With some functions, like sine of x, a single output can have an infinite number of preimages. For example, the output 0 comes from the inputs 0, pi, -pi, 2 pi, and on forever.
All right, let's bring it all together. We have our tools. Now let's see how using them correctly helps us move past all that earlier confusion and into a state of, well, real function clarity.
This little table is super helpful. It basically acts as a translator between the casual language we often use in school and the super precise terms needed for higher-level math. The big one to notice is how range is often used informally to mean the actual outputs, but in more rigorous math, we call that the image to distinguish it from the codomain, which is the whole target area.
And this really is the bottom line, isn't it? Why bother with all this picky vocabulary? What's the real payoff?
Here it is. Mastering this language is how you develop what's called function sense. It's not just about memorizing words. It's about being able to clearly and confidently describe what a function is doing, what can go in, what might come out, what really comes out, and how do the inputs and outputs connect. That's power.
So let's do a final flyby. The domain is where you start. The function maps it over to the codomain, which is the whole target. The image is the specific part of that target you actually land on. And the preimage lets you look back from a point in the codomain to see what, if anything, in the domain got you there. See? It all fits together.
So I'll leave you with a little challenge. With this new toolkit in your head, take another look at a function like the absolute value of x minus 5. How would you describe it now? What's its domain? What's a reasonable codomain? And what's its actual image? What's the preimage of, say, the number 3? Thinking that through is how you truly make this language your own.